Good day and welcome to this video in our series teaching C#.NET for engineers. In this video we are going to take a deeper look at dictionaries. In the previous video we defined what dictionaries are. In this video we are going to extend the use of dictionaries to hold two-dimensional data. So as I said in the previous video, we looked at the definition of dictionaries. We showed with a hands-on demonstration how to create a dictionary in C# and how to add keys and values to your dictionary. And we also looked how to get a value matching a specific key. Now in this video we are going to have a look at using dictionaries for two-directional lookup, which is a very important technique which I will be using in some of the follow-on videos where we are actually going to read data from Excel and then use that data to do something useful with. So this video may be a little bit complex initially. Please just re-look at it, make sure that you are really comfortable with the concepts in this video. Now in the previous video we created a dictionary to hold where the keys were road IDs and the values were the road names, and we showed how you could very quickly get the road name related to a specific key or road ID. Now what we want to do now is to extend it so that we don't only get the road name, but we get the entire set of columns, and we can then easily extract the value for any column. Now the way to do that is to simply see each row here as a dictionary in itself. So if I take this row, for example, with the column headers and I transpose it, I get this type of data structure. And you can see this immediately has the appearance of a dictionary because I've got a set of keys here on the side and I've got their values. Notice some of the values are strings and some of the values are numbers. So the keys are strings, but the values can be either a string or a numeric type. So I'm going to have to declare the values as an object type, which means that at runtime that could take on any type of variable type. So the way to represent a single row which has been transposed like this is simply by declaring it as a dictionary with a key is being a string and the value is being an object. And I'll just call this variable row so that it's easy to understand. And the string which represents the key is then the column name, and the value is an object. That is the column value. So once you understand that any row here can be interpreted as a set of keys and values where the keys represent the column names and the values represent the values in that column, then it's easy to extend that to understand that a table will then simply be a list of these rows, right? That's what a table is. It's a list of rows. So we can represent a table as a list of dictionaries. We looked in one of the earlier videos how you define a list. It's basically just you declare it as list and then an object type, and you can give that variable a name like my list. And in one of the previous videos we showed how you create lists like this where the object type is a double precision value or an integer or a string. So if you are going to use this type of list to hold our rows, then simply instead of putting an object such as a double type in there, we put our row object, which is a dictionary, in there, and let's say we call this variable my table. So this red part that you see here corresponds to this object part, and that simply represents our row object. So this is again the column name, and that is the column value. So it's simply a list of dictionaries that I'm keeping to represent my table. So that's a very nice and compact way to do that. My list can grow and shrink as I read in more data from a file or a spreadsheet or whatever. The problem, however, if you use a list to hold your data like that is how do you quickly find a row? And so we showed in one of the previous videos that a list can only be, you can access it by using the element index, like this number on the side here, to get a specific row. But what do you do if you quickly want to find a row ID? So the solution to that is that instead of using a list to hold all your rows, you use a dictionary to hold all your rows. And in this dictionary, the key is the column that you want to use as the index lookup value for your table. So you're going to use row ID as the key for each row. Now that data structure will look like this. So you're going to have your row, is this what I've highlighted in red, and the table is then represented by this entire thing, where the table is represented as a dictionary where the values are the rows, and there you've got the column name and the column value, and the key here is then your row index, row ID. Right, so how do you, if you've done that, how do you extract the value of a cell? Now remember, in the previous video I said to get the value associated with any key, we just use the square bracket notation and then enter the key in there. Now you will do the same. This is the structure of your table. It's a dictionary where the keys are the row IDs and the object or the value is the row objects, where this key is the column name and this is the column value. So to extract then the value, for example, to get the surface age value, this one here, for the row where the row ID is C9985, I am going to use this notation. So I'm going to extract the value into a variable which I call surface age. The data type is double, and I'm going to say my table, this returns the row, and this returns the value in column surface age. So that's the way that we basically do it. We are just chaining together the two lookups, one for the row and next to it the lookup for the column. Now there's one problem here, is that since this value here returns an object type and not a double type, I will have to do a type conversion of this value. Otherwise Visual Studio will not allow me to compile this, because I'm trying to assign a double type to an object type, because this returns the object. So we'll do that when we're looking at our code. So let's go and do this in a hands-on demo quickly in our project that we've been building up to now. So here is the app that we have been developing as just to demonstrate the concept. So I've got my solution here with a library project and an app, and these were all discussed in the previous videos. And I've got my program.cs file here. I'm just going to delete again everything there. And what I'm now going to do is to just ask ChatGPT to help me to build that dictionary, which consists of a set of rows. And I'm going to just go and take this value in my Excel table like this. I'm going to go and copy this. So I'm just going to go over to ChatGPT and I'm going to say in C#. And now I'm going to shift enter and I'm going to paste my data in here. But before I send this to the robot, I'm just going to enter down here. Okay, so there I've sent it now to ChatGPT, and as usual it comes up and it basically writes for me a small little program. I'm just interested in this data here, but as you can see, it's done it in a very compact way, which if you are a beginner watching this video is going to be a bit confusing. So I'm just going to add here the request that add each. So now you can see it's defining it for me a bit more. It's not as compact, but it's a bit easier to understand. And I'm going to just copy this code all the way down here, and I'm going to put that in my Visual Studio in my program.cs, and now we can take a closer look at this, what ChatGPT has written for us. So we can see here I've got my variable row data, which is declared as a new dictionary of type string. That's the key, and the value is then the dictionary string object. So this part that I've highlighted here will be my rows, and this will be my index to look up a specific row. Now let's see how ChatGPT has defined each row. So I'll put my spreadsheet right next to it here, just like that. And you can see that my first row has got the key here as which is the key, and then I say that's a new dictionary, and it adds all of these values here, which is that first row in there. So you can see that's basically the way that each of these rows have been added. And then ChatGPT also added for me a little loop here to loop over the data. And I want you to just pause the video here and go and have a look at this little structure here, this little code snippet, to see how you loop over a dictionary and extract data from the keys and the values. It's really important. I'm not going to talk you through this line by line, but by now it should be possible for you to start understanding how these type of loops work. Let's run this and see how it comes out. All right, there I've got my row ID, and it prints out each row for me, just like we would expect. Now let's just go and use the example that we showed earlier to see how we would extract a specific value. And I'm going to say let's get the value for that row ID. So I'm going to say just like we showed in the PowerPoint presentation, double surface age equals row data, and I'm going to put the this value in there. That's the key that I'm looking for, and the column that I'm looking for is surface age. Right now, as I said in the conceptual explanation, here I've got a red line because it's saying here you cannot implicitly convert a type object to a type double. So that's not a problem. We just have to explicitly convert it. And as I showed in one of the earlier videos, the way to do that is to say convert to double. You can see how Visual Studio helps me here. I don't have to remember all this. I just have to remember more or less to where to start looking. So I'm going to say to double, and now I've got to put this in round brackets like that. So have a careful look at this line here, and then I'm going to write that to the console. Surface age of row and so on. So I'm going to run that. There's my output. So again, it prints all the tables, and here at the bottom it says the surface age of road C9985 is 24.5, and we can go and see there C9985 surface age 24.5. Okay, so that's it for this video, and as I said in the introduction, it's really important that you are comfortable with the concepts explained in this video, because in later videos we are going to make extensive use of this type of bidirectional lookup using a dictionary of dictionaries. So go back again over the code. If it is not clear to you, please keep at it until you have everything crystallized. You should have an aha moment where you understand how this type of lookup works, specifically this type of complex lookup of chained lookup, where you have a bracket to look up the first value and then a bracket to look up the next value from the result of the first lookup. So it's very similar to a VLOOKUP in Excel, but here you are doing a lookup on row and column at the same time, and you can see how compact you can actually do that. Now, of course, you won't always, if you're reading data, a table's data from an Excel spreadsheet or a CSV file, and you've got 1,000 rows with 50 columns, there's no way that you can actually go and type in the data like this. So we're using this type of manual declaration of our data only for teaching and demonstration purposes. In a later video, I'm going to show you how to do the same thing, but reading data from a spreadsheet or from a CSV file. But it's very important by the time we get to that video where we're starting to do some engineering stuff, that the basic principles, such as I've demonstrated in this video, are already familiar and well established in your experiential curve as you learn C#. So that's it for this video. I'll see you in the next video. Thanks for watching.